Let us calculate the empirical formula, children. From the given data, they already give the percentage composition. The element carbon percentage is 32. So we wrote in the tabular column, we have totally 6 columns. First one element, second one percentage, third one molar mass, fourth one relative number of moles, fifth one simplest ratio, sixth one simplest ratio in whole numbers. Let us do, first we are going to calculate for carbon. The element symbol is carbon, so we are putting C. Then percentage given in the example 32%. So we wrote 32. In molar mass of carbon is 12, so we wrote 12. Element is C, carbon, given percentage is 32, molar mass is 12. Then we are going to calculate the relative number of moles. How we got to calculate? By divide the given percentage divide by molar mass. So 32 divided by 12. By the calculation we are getting 2.66. Then simplest ratio. We can move to the simplest ratio after calculating the relative number of moles for remaining hydrogen and oxygen. Then we move to hydrogen. The given percentage is 4. Molar mass is 1. So what is the relative number of moles? 4 divided by 1, that is equal to 4. Then for oxygen, given percentage is 64. Molar mass is 16. For oxygen, molar mass 16. The relative number of moles is 64 divided by 16 is equal to 4. Children, to calculate the empirical formula, we must memory the molar mass. The percentage alone they give in the problem. So we must memory some of the elements molar mass. At least carbon, hydrogen, oxygen, nitrogen, these elements we must remember. Then we move to the simplest ratio. Now we calculate all the relative number of moles for each element present in the compound. C, hydrogen and O, CHO we calculated. We compare these 3 relative number of moles. Which is smallest one? For carbon alone, smallest one. Yes, it is 2.66. So the next step, simplest ratio. To calculate the simplest ratio, we must divide the relative number of moles by smallest one. Isn't it? Here the smallest one is 2.66. So for carbon, 2.66 divided by 2.66, that is 1. Then for hydrogen, we know relative number of moles is 4. So 4 divided by 2.66, that is 1.5. Then for oxygen, we already know 4, the relative number of moles. What is the simplest ratio? 4 divided by 2.66, that is 1.5. Now we calculate the simplest ratio for carbon, hydrogen and oxygen. Check the simplest ratio, children. Is all the numbers are whole number? No. Only carbon alone whole number. Rest of the hydrogen and oxygen they have 1.5, 1.5. What is the condition? The smallest ratio should be in whole number. So we have to convert the simplest ratio to the whole number. How? By multiplying with suitable smallest number. Here we are multiplying with 2. Then we get the whole number. 1 into 2, 2, 1.5 into 2, 3, 1.5 into 2, 3. We may ask the question, why we can directly convert 1.5 into 2? It is wrong way. Here, this is a ratio. We are calculating in the term of ratio. So, we can't do the conversion 1.5 to 2 directly. By simply, we have to multiply with the simplest number alone. We have to convert a simplest ratio in whole number. That is the reason we are multiplying all the simplest ratio by 2. So now we got the simplest ratio in whole numbers. For carbon 2, for hydrogen 3 and for oxygen 3. So what may be the empirical formula? C2H3O3. C2H3O3. This is the way we can calculate the empirical formula from the percentage composition.